Okay, so with this video, I want to do one more multiplication of polynomials, and followed by the starting factoring to get into the subject of factoring. So multiplication of polynomials is R4, factoring is R5 in your book. Okay, so I've got, what's my title? My title for the moment is still multiplication of polynomials, and it's really radicals. Actually, I'm sorry, it's really radicals. We got to finish off multiplication of radicals. So I apologize. It's part of the same section, polynomials and multiplication of radicals. Anyway, so this is the last thing that we have to do. I think I'm up to calling it problem number 3. I'm pretty sure that's what we're up to. And here's what it looks like. 4 square root of 5, 4 square root of 5 plus square root of 6 times 4 square root of 5 minus square root of 6. And here you might be seeing something funny over here that we've done before, something similar. We did it with regular polynomials. Now we're seeing it with radicals. They are conjugates of each other. Here it comes again. Conjugates. Very important to remember about conjugates. This term is the same exact thing as this term. This second term in the binomial is exactly the same as this term in the second term in the binomial on the other side. The only difference between is one has a plus in between the two terms and one has a minus. They are conjugates of each other, and it's going to make a huge difference what's going to happen next. So let's go through this routinely. There's nothing super special going on here as far as working it out. 4 times 4 is 16. Square root of 5 times square root of 5, we learned already that that's going to be turned into 5 itself. We'll clean that up later. Don't worry about it right now. First times first. Outside times outside is 4 is going to turn into 4 times what's in front of here? A 1, right? And whatever's in front of, just like in front of an x, it's a 1. Whatever in front of every x, there's an invisible 1. In front of every radical, there's an invisible 1, right? That's separate from what we're doing here. So it's a little aside there. So there's an invisible 1 there. So what's the 4 going to multiply? It's going to multiply a 1, but not just a 1, a negative 1. So positive times negative is negative 4. What's square root of 5 times square root of 6? Square root of 30. Okay, what's the invisible number right in front of this square root of 6? It's a 1, a positive 1. Positive 1 times positive 4 is positive 4. Square root of 6 times square root of 5 is square root of 30. And finally, square root of 6 times square root of 6, right? Square root of 513 times square root of 513 is 513. Square root of 6 times square root of 6 is 6. But be careful. Plus times minus, positive times minus, is minus. What happens in the middle here? The conjugates. We had 2 conjugates multiplying each other, 2 binomials that are conjugates of each other multiplying each other. The predictable happened. One is a minus 4 square root of 30. One is a positive 4 square root of 30. They cancel each other out. All that's left standing is 16 times 5, which is 80. We didn't clean that up yet, but we're doing it now. Minus 6 equals 74. Final answer. So when you got 2 conjugates of radicals multiplying each other, it turns into a regular normal number at the end. That is pretty crucial. That'll come up later on as well. Okay, so that's it for multiplication of radicals. We now go on to our new topic, which is in R5, which is factoring. It's a pretty long topic. Okay, so I'm going to mark this video radicals and factoring A. That's what I'm going to mark this. I plan on marking this video as. It's mostly going to be about factoring. Okay, let me move the paper up, right, just to get maximum story here. All right, our first factoring problem. This is coming from R5, first factoring problem, is as follows. We're going to start out with obviously a simple problem. Well, I guess I'll call it problem number 1. 2x squared plus 12. And we're supposed to factor this. So there's another vocabulary word over here called the GCF. And that stands for greatest common factor. That's what GCF stands for. I want that to the side so it doesn't interfere with what we're doing. Okay, what's the greatest common factor that we can get out of here? Well, there's no x counterpart. There's an x squared here, but there's no x's over here. But there's a number, a regular number, and a regular number, and there's a number that will go into both 2 and 12. We're looking for the greatest number. We're looking for the greatest common factor, the greatest number that will go into 2 and into 12. And that number, right, we're starting off slow, is the number 2. That's all we can do. That's the best we can do. So you write a number 2 on the left-hand side and then write a blank parentheses, and we plan on filling that up. But I need a little scrap paper. This is our next step. After figuring out that 2 is our greatest common factor, we put it on the left-hand side. We have an open parentheses waiting for some stuff, but bear with me. Here's what we got to do. We got to take the first term, 2x squared, and divide it by, guess what? 2. And then we got to take the second term, 12, and divide that by, guess what? 2. All right. 2x squared divided by 2, these cancel each other out, so it just turns into x squared. And 12 divided by 2 is 6, plus 6. This factoring problem, we're starting off slow, obviously, is over. We have factored. That's the answer. We have factored this this binomial up here, and we have turned it into 2x squared. If you want to check your work to make sure that you got it right, well, the one way of doing it is it gets a little bit more complicated as we go on in factoring. So, but at least at the start, all you got to do is multiply 2 times x squared, you get back to 2x squared. 2 times 6, you get back to 12, and you pretty much know that you're on the right track. Okay. That was problem number 1. We have some more time. So now what do? I go and get my next page. Close this page. And let me fetch another page. There we go. Okay, so now I can put up on the top, I don't always put up on the page 2 what the title is, but since we're into factoring, I'm going to do that. Factoring is what we're all about right now. Okay, so now problem number 2 in factoring, and again, we're not going quickly here. We're going slow. What if you have 4x squared, right, plus 16x cubed, and we're assigned the same task? We are supposed to factor this. Okay, it's going to work very similarly to the previous problem. We're going to have a parentheses. We're going to fill that. We need to fill that parentheses with content. Well, you're going to be using some scrap paper. Not yet. Hold on. But let's first figure out what the greatest common factor is of our problem at hand. Well, look at the two numbers, 4 and 16. What is the greatest number that will go both in 4 and 16? Obvious, 4, but I'm putting it a little bit over to the left. You'll see why in a minute, or less than a minute. 4 goes into 4 and 4 goes into 16. It's the biggest number that I can think of that will go into both. What about x2 and x cubed? Can something go into both x2 and x cubed? Yes. x2 x to the second power can go into x2 and x3. It'll always be the smaller of the two. The smaller of the two will go into the smaller one itself, and it will also go into the other x if it's higher. It'll be fine. So you pick the smaller of the two to bring out as your GCF. My GCF is done. This is my GCF right there. What do I do on scrap paper? What do I do on scrap paper? Take the two terms. One of them is 4x squared divided by, guess what, 4x squared. And take the other one, 16x cubed, and divide that by 4x squared. Okay, very good. 4x squared over 4x squared, everything cancels out. It just turns into a 1, but don't let it disappear. There's a 1 here. Then there's going to be a plus. And now let's check this out. 16 divided by 4 is 4, wins up on top. 16 divided by 4, 4 on top. X cubed over x squared, 3 minus 2 is 1. Remember, x to the fifth over x to the third is x to the second. Remember our rules? Those 4 rules I kept putting up? x3 divided by x2 is just plain x to the 1. So it turns into x to the 1. And what do I fill this in with? 4x. We have successfully factored this. We got the GCF out, we worked it out, and we have factored problem number 2. On your answer sheet, they may not like what this looks like. They may much prefer 4x squared times 4x plus 1. I can't guarantee exactly what your answer sheet is going to look like, but just if you did this, then you are 100% correct. You just got to make sure that you answer it up, and let's say they say answer D is 4x squared times 4x plus 1. You got to realize that you got the right answer, and you just put it in a different order. Okay, we've done that one. Let's move on to the same basic stuff, right? Factoring has got a bunch of facets to it. Won't be over with factoring for a little bit, but something similar to problems 1 and 2 is coming up, but just a little bit harder. Nothing terrible. What if you've got 12x to the 5 plus 18x to the 4 minus 24x to the 3? Now what? Okay, you open up a parentheses. This has got to have 3 terms in it, so I got to make it a little larger. Those were 2 terms. The first 2 problems were 2 terms. Now we got 3. I make it a little larger, and we got to figure out what our GCF is. We got to figure out what our GCF is going to be on the left-hand side. So the first thing we do, we got to let's play. I'm going to need scrap paper again for this problem as well. Bear with me. Our scrap paper. Okay. Now let's go to the numbers. 12, 18, negative 24. What is the highest number you can think of that will both go into 12? I'm sorry, into 12, to 18, and to negative 24. Well, what number will go into all 3 of those numbers? Highest number. Answer 6. I put it a little bit to the left to leave some room. 6 will go into 12. It will go into 18. It will go into 24. And there's nothing higher that will go into all 3 of those numbers. So I got my 6 out there. What about the x's? Always pick the smallest. x3 is the smallest. x3 will go into x3, it'll go into x4, and it'll go into x5. So there's my GCF. I have my GCF. It's done. It's on the left-hand side of the parentheses. Now I got to fill in the parentheses. How do you fill in the parentheses? The same way we did before. Take the first term of the problem, 12x5, divide by GCF, 6x cubed. Then take the second term of the problem, 18x4, divide by GCF, 6x cubed. And then take the last term of the problem, that's a 3, and divide by GCF, 6x cubed. Let's see what happens. 12 divided by 6, 2. All right, so that's going to be going in there, 2. x5 over x3, classic. It's x squared. Classic. The next thing is 18 over 6, 3. It's equal to positive 3. Positive 3. x4 over x3, 4 minus 3 is 1, so it turns into just plain x to the 1 power, also known as x. Last one. Minus 24 over 6 is minus 4, right? Minus divided by positive is minus. Minus 4. That's the numbers. There we go. And x cubed over x cubed is 1. So don't put a 1 here. Minus 4 times 1 is minus 4. So leave it alone. Minus 4. That's it. We're done with this problem. Here is the answer. We have factored. We took the GCF out of there. That is what we're for the moment. That's all we need to factor. That's all we need to show. We're going to show more stuff about factoring where we'd be able to continue with this factoring, but we're not doing that right now. We're showing simple factor problems. Okay, I end the video at this point.